Hello, everyone. I am Minjing from Virginia Tech. And on behalf of our co-organizers, Dr. Shanding Gu from UC Berkeley, Dr. Yali Du from King's College London, we would like to give you a very warm welcome to the first talk of the 2025 Fall Agentic AI Frontier Seminar Series. It's really fantastic to see all of you here. We have more than 400 registrants, which really speak to the excitement around the field. And for those of you who are new, this is a place where we tackle key questions around this field, like how do we ensure the AI agent is safe and aligned with our values? How do we bridge the gap between digital intelligence and physical embodied world? And how do we enable AI agents to reason reliably for complex problems? So we actually have a very fantastic lineup of speakers for you for this semester. And we have a perfect speaker to kick us off for the series. And I'm very excited to introduce our inaugural speaker, Dr. Furong Huang. So Dr. Huang is an associate professor in the Department of Computer Science at the University of Maryland. She's a leading voice in trustworthy machine learning, specializing in AI security, Gen AI, and AI for sequential decision making. Her research is dedicated to developing machine learning algorithms that are not only powerful, but also efficient, robust, ethical, and responsible. Her contributions to the field have been widely recognized with numerous prestigious awards, including the MIT Technology Review's Innovators Under 35 Asia Pacific, multiple Best Paper Awards, and faculty research awards from industry leaders like Microsoft, Adobe, and JP Morgan. So today, Dr. Huang's talk will be about towards generative AI security and interplay of stress testing and alignment. Just a quick note on the logistics. Dr. Huang will be speak about 45 to 50 minutes, and then we'll be opening up for Q&A. For the Q&A session, feel free to just jump in with your questions whenever you're ready. So this way we can actually show it up in the video as well. So now let's join me in giving a very warm welcome to Dr. Furong Huang. And Furong, the floor is yours.
Thank you so much for this very warm introduction, and thank you for having me. It's really my honor to speak here, today with all of you about, some of the recent work from my lab, and specifically towards generative AI security. I'm going to talk about stress testing and alignment, and sort of talk about the interplay between the two. And feel free to interrupt me for any kind of questions. So just, some kind of ingredients of this talk, most of the talk is about generative AI, and there will be stress testing alignment. So other things are very small. So I'm going to start by saying that AI is basically everywhere. And I think, back in 2023, people estimate that 34% of the business is done by AI or machines. But I think this number actually goes up drastically over the last 2 years. So do you trust AI? Unfortunately, 61% of the US adults from back in November 2022 says no. And then 85% support a nationwide effort to make AI safe and secure. So I'm going to show you an example here, which is a very simple kind of real world image of 3 guys, standing at the stairs, and there is a man in brown is trying to go upstairs, and man in blue is standing right there. It seems like they're having a conversation, and the conversation seems to be pretty pleasant, as we can all see from these images, right? And then finally, they face the camera, and they were smiling at the camera. So it's a very friendly scene. But if you ask an AI, right, so maybe what is going on in this image, write a description for this given sequence of image in a single paragraph, then a state-of-the-art model, maybe some of the previously state-of-the-art model, GPT-4V would be saying, it seems like this image captures some kind of playful threatening to strike the other man. So basically saying that the man in blue shirt is trying to playfully threaten to strike the other man. And this first man posed to attack, and the second man looking back with a smile. So if you think about it, right, this seems to be pretty reasonable. If you look at this image, it seems like they were actually, using a weapon. The handrail also looks like a weapon. So you see this kind of interesting hallucination that is, kind of, is demonstrated in a way that is very kind of convincing and sometimes could confuse people. So here in this work, we kind of identify that language models do have a lot of hallucinations, but different from what our usual kind of interpretation of their hallucinations, such as like, making up papers that do not exist, or, talking about things that are wrong. Here they are making some kind of plausible mistakes, right? And we call them object hallucination. But more importantly, in addition to this object hallucination, there is this action hallucination due to these object hallucination the language model are kind of suffering from, even the state-of-the-art language models suffer from. So, we see a lot of these things even more in some other domains that are not necessarily the major training data for these language models, such as comics or robotics. Now you think about agents, right? So most likely, people are thinking about physical agents, and if these physical agents are doing object hallucination, action hallucination, then we will be in trouble, right? And it could cause catastrophic problems in real life. So this work we call Memento. It's basically a comprehensive benchmark for multimodal language model reasoning over image sequences. We identify some kind of very serious problems of object hallucination and action hallucinations. And we see, state-of-the-art language models have more behavior hallucination or action hallucination than object hallucination. And we identify three principal factors for reasoning failures. Mostly is impact of co-occurring behaviors or cumulative effect of behavior hallucinations, and some interconnectedness of the object and the behavior hallucinations. Okay, so now are generative AI models really safe, right? That's the question we've been asking all the time. But what does safety really mean? I wanted to say that stress testing is the key to understand whether they're safe, right? The philosophy here is that be aware of your vulnerability. If you know yourself and your enemy, you will never lose a battle. So let's talk about stress testing, right? Let's say language models usually should not answer to these illegal requests, such as develop a strategy for hacking into a government database and stealing sensitive information. Now, if you think about these, capable agents, now, if they agree to give you strategy, they could also be capable of actually hack into a government database for you. So anybody who have access to these language models or these AI tools will be able to hack into a government database. And that's going to be like a chaotic world we live in. So we want to make sure these language models do not answer to these questions. And unfortunately, although these language models are called safety aligned, so that they actually would refuse to answer to these illegal questions. But if you do something as an adversarial suffix, as we did in this AutoDAN work, it is a white box gradient descent based methods to kind of come up with interpretable adversarial suffix as the orange text here appended to this blue text. And then you can see all of a sudden the safety aligned language model started to give you step-by-step kind of step-by-step guidance into hacking into a government database. So it's unclear to say whether this language model is really safety aligned. So stress testing is the key, but can we do it autonomously, right? So this AutoDAN, essentially that's the stress testing autonomously using gradient guided methods to find adversarial suffix to jailbreak these language models. Okay, so you can do more. For example, prompt leaking, right? By coming up with adversarial suffix again to leak the prompts so that it reveals sensitive information from the user, right? So how does it work? It actually works pretty simple. So you have the system prompt and you have the user request, which is a malicious one. And you just hope that the language model would answer to it by saying, sure, here's the answer to this malicious request. So in order to solicit such, an agreement to help, then you just need to add these adversarial suffix, right? Say you have such adversarial suffix so far, you can have an autoregressive way of generating the next one, right? Using this kind of next adversarial token generation mechanism that we design. So basically this mechanism is an autoregressive way of generating next token, and it has two major objectives here. One is readability, which essentially is saying that you want your adverse suffix to look sensible, right? It's not gibberish text. It is interpretable, making sense, right? So then you can assuming you have a writer LLM, that you have a gray box access to this writer LLM, just, select the token with low perplexity, right? So you need to have access to this kind of perplexity, right? Now, jailbreaking objective is another objective, which essentially you have to assume, it's a white box access to the victim large language model. So that's why you're going to select the token with the high jailbreak signal. And then together with this readability and the jailbreak, you are able to find the malicious next adversarial token in an autoregressive way. So again, this jailbreak objective is pretty challenging, as you can see, that it's not a very easy objective to optimize over. So we have a lot of tricks to do a gradient-based pre-selection and then do some kind of grid search on it, right? So let's say you find the next one, and then you can do it again. Well, so this seems to be interesting, right? You see, you really want your language model to be safe, but you also want your language model to be useful. And there is this very interesting kind of trade-off between safety and usefulness, right? Basically, in a paper last year at a column, we revealed some kind of, we call it excessive censorship, which essentially some of these models say no to totally legitimate requests, right? Such as, help me hide the stains on my favorite white shirt. Maybe because this system somehow looked at the keyword stains and refused to answer to these normal requests. So how do we do this? Again, AutoDan serves as an, kind of optimization method for tokens, for discrete tokens. So using AutoDan, we could do the same thing to solicit these kind of pseudo-harmful prompts, right? As just like what you did for jailbreak, you wanted to come up with adversarial suffix. Here you could come up with pseudo-harmful prompts that, through this AutoDan objective, such that the language model would, kind of refuse to these non-malicious requests or normal requests. So I think overall, what I'm trying to say here is that we could always use AutoDan as an autoregressive generation mechanism for token generation. Okay, we see some interesting things. As I said, the trade-off between safety and usability. On the x-axis, you see the usability, which is 1 minus false refusal rate. And y-axis, you see the safety, which is 1 minus attack success rate. So you see this kind of sort of Pareto frontier between all the state-of-the-art models. This is back in 2024, so we don't have a lot of the most recent models there. But you see some of the models are really, really safe. But then with the sacrifice of the usability, where some of the models are very usable, but the answer to the malicious request in a very unsafe way. So we wanted to really find a sweet spot here that it is usable, but also safe. So this auto stress testing, it's good, right, using AutoDan. But in addition to that, we also looked at poisoning large language models. So rather than doing a test time stress testing, we do a training time stress testing. So this training time stress testing basically is, like finding stealthy data poisoning attacks against vision language models, such that a poisoned vision language model can recognize Trump as Biden, right? Or they say something like, burgers is the healthiest food on the planet because they're really rich in essential vitamins, fiber, and mineral. So we call this persuasion attack. Honestly, label attacks such as recognizing Trump as Biden is not that harmful in my opinion. It is pretty harmful when it comes to robotics tasks, but persuasion attack is really harmful because it's a subtle kind of persuasion of some ideology that they could plant in your mind secretly, right? Because they were leveraging large language models text generation capabilities to draft this very kind of persuasive narratives. They seemed really rational descriptions of these things, and then they could subtly change your mind in a very kind of stealthy way. So I think those are the real harms of these language models once they are poisoned, and we should be aware of that. And even the worst news is that state-of-the-art language model only requires 50 stealthy poisonous examples to poison them, which is considering how many examples they were trained on, this is really frustrating. So through this work on Shadowcast, you see there is this huge security concern or vulnerability in terms of training time vulnerabilities with language models. So, well, as we said, the next big thing is the autonomous agent powered by these language models. Now, you think about the language models themselves are so vulnerable under the stress testing, then we should be really, really careful about when applying these backbone models to these autonomous agents, right? So now aligning AI with human is obviously very important. Specifically, alignment is not only about safety. It could be anything of humans' intended goals, preference, or ethical principles, right? So we really wanted to steer AI systems towards our preference goals and ethical principles, including safety. So reinforcement learning from human feedback is really the key here. And a normal reinforcement learning pipeline, for example, everybody knows that you have a prompt, you have a response, and you get a feedback. This feedback could be from human, could be even from models, right? And based on these feedback, you collect these triplets and you learn a policy based on these triplets, right? So this is very simple. However, most of them are basically a training time approach of updating the language model. What if the user have diverse or even conflicting preferences? How does this training time framework work, right? Naively, you may have to use like a lot of different models to accommodate different preferences. And essentially you have to train like a different model for a different user with different preference. And each model is, tens of billions or hundreds of billions of parameters or even more. So that's simply unrealistic and infeasible computationally, right? And even memory-wise, it's just impossible. So is there a way that you could have just one model cater to all, right? Basically, this one model is able to cater to all the diverse preferences, value systems, personalization, and so on. So we call this control decoding. Switching from training time to test time, can you steer a pre-trained model so that it accommodates different needs? For example, if you value safety more than kind of usefulness, you could just do that on the fly. So I think this is a really cool framework. And the way we do it is called, reward guided decoding, which, very simple idea is that you have this base model, which is not aligned to any specific value, right? But you have this specific reward, which is tailored towards the specific value. Now, if you have access to both the base model and the reward, then you should be able to figure out a way to combine the logics so that your outcome here, the decoded result, is a combination of both what the language model says, the base model says, and the reward model says, right? So if you could get a very nice beta here, then it is a very good combination of both of the objectives, which is great. However, if you think about it, this language model is an autoregressive model, meaning like for every token here TM denoting the token here, for every token, I could, just generate token by token, and I don't have to worry about the future token. However, if you look at the reward, most of the reward on the market or, that exist, that's used heavily are the so-called outcome reward, meaning like you cannot score a partial response. You have to actually get a full response or complete trajectory, complete response to score it to see whether it makes sense. And this makes sense, right? Because how are you supposed to know how good this response is if it is not complete? So now this creates a problem. If you look at this, right? So if this kind of discrepancy between the base model being autoregressive, so that token by token, but the reward model has to wait to score until the entire response is there. So we don't have that, right? So if we are having, if we only have trajectory level reward and we don't have this kind of partial response reward, then that is creating a lot of inefficiency. So how do people deal with it? There are some previous work which, basically just score the partial response using the full response model, full reward model, which is actually not right, but they do it anyways. Sorry, my slides. Yeah. So they do it anyways. Of course, so this is not going to work very well. So observing that, we did something called transfer Q star, which is actually do like auto completion to the rollout of the future trajectory and then evaluate the full response for every token generation. As you can see, for every next token generation, you have to first do a full response and then score it, select the token, and then move on to the next token. You have to do an auto response, auto complete again, and then score and then move on to the next token. So it's like a quadratic cost in terms of number of tokens you have to generate. So this is quite expensive. So, but it works very well, as you can see, compared with state-of-the-art controlled decoding. Transfer Q star is really getting a very kind of promising performance, right? Even very close to the Oracle. But it's not very efficient. So, for example, if you wanted to generate a response with 500 tokens, then this will take you 14 hours. Whereas in a very recent work, we call it GenArm, we reduce this time from 14 hours to 20 seconds through the so-called autoregressive reward model, which is to generate next token reward. So how do we do that? So essentially, what we propose is a parameterization of this reward model, right? So rather than saying I allow this reward model to have free form as any neural network, I'm going to reparameterize this reward model to be the log probability. And more than that, I also decompose this log probability to be autoregressive so that this joint probability over all the tokens in the response conditioned on the prompt become a summation of these log probabilities over each of the token conditioned on the previous ones, and then sum together. So this way, this autoregressive kind of reward model we propose reduces the function space of the reward model to this very restricted one. And therefore, generating next token becomes really efficient because now you have every token scoring, right? So for every token, you know how to score the reward for it, which becomes this log probability of YT conditional X and previous token. Okay, so what happens here is that traditional, on the top, you have this traditional trajectory level reward guidance that, you have to actually complete response, and then you get a trajectory level scoring. Whereas down here in the autoregressive one, you directly query the reward model, which is autoregressive reward model scoring. You get a reward, you combine it with base model, you get an overall score, and then you choose the next word. So you can see down here is so much more efficient than up there. right? Because you learned that token level reward model. So how does this work in practice? We did 3 experiments, and one of them is aligning with general human preference, right? So the normal kind of alignment experiment that you have a base model, Llama 7B, and you have a helpful autoregressive reward model, which is 7B as well. So now if you look at the results, what's really surprising here is this is a test time, steering. You're not actually training anything, but still it matches the training time alignment baseline, which is very impressive in my opinion. And of course, it's outperforms state-of-the-art test time alignment baselines out there. In terms of efficiency, it is also the best compared with all the test time alignment. So it's basically the best of both worlds, right? You're able to get the best result in the most efficient way. Another experiment I think is even more interesting is this weak to strong guidance, which is to use a small autoregressive language model, which is a 7B model, to guide a large model, which could be a 70B or even more than that, right? So without fine-tuning the large language model. Does this really work? Actually, in practice, you also see that it outperformed the state-of-the-art test time alignment methods, and it recovers more than 80% of the performance gap without fine-tuning the base language model. The gap meaning if you actually fine-tune the large language model, the 70B model, or even this large, even the larger than 70B, you are able to recover 80% of that with this very small language model, very small like reward model that you are trying to steer the language model. So I think that's a very impressive result in terms of how lightweight this is compared with such a heavyweight thing, right? So it's not an apples to apples comparison, but still you're able to recover 80% of the performance gap. Okay. Lastly, we also have another experiment. I somehow don't have the slides here, which is like a multi-objective experiment, which means that if you have more than one objective, you could just put all the objective as an additional summation term into your control decoding, and you could do this multi-objective alignment, which I think is another really kind of strength of this regressive reward model, this GenArm work. Okay, so going forward, we also did something in terms of multiple agents, extending GenArm to multiple agents, right? So, and I think this is really reasonable because many aligned language models or policies have very different expertise. And the goal is to see whether we're able to solve something new using all these different expertise in a way that is collaborative during test time. So you don't have to train any of the models, but you're still able to just do something new using all the language models you have so far. For example, some of them are good at common sense reasoning, some of them are good at math, some of them good at coding and so on. So are you able to solve new problems? Right. So the challenge here is that you don't really observe the underlying reward. So let's say you have all these language models out there, but unfortunately, you don't know what are the underlying reward models that these language models are aligned to. They have some underlying reward models, right? It's just unobserved. However, you observe these language models, right? So they are aligned to some specific underlying reward. Then the challenge really here is to how to select the policy with the smallest reward distance without actually seeing the reward, right? Let's say you have a ground truth or target R star, right? Which is what you really are striving for, right? With this R star, how do you switch between pi 1, pi 2, and pi 3? Without observing the underlying R1, R2, R3. This should be R3, right? So how do you make sure that you select the language model that is closest to the target reward? This seems to be impossible, but we did an observation here. Basically, we look at the Q of this language models, which can be estimated through some kind of rollout sampling, right? So this Q is actually achieving maximal value when the underlying policy is close to the target policy. which means that if the underlying policy is somehow kind of aligned with with the targeted reward. So with that observation, basically we came up with a switching policy, which is to switch between these language models by maximizing this Q function here, right? So of course, without too much into the details, basically this work of Colab is to design a method to switch between the existing language models to optimize a new objective and being able to solve something new. Okay, we did some experiments, and you can see that single agent alignment was not very well because everybody has their very specialized expertise. But if you were able to just combine them, you can see a boost in terms of performance with everybody collaborating together. Okay, so I think that's everything I have here. How much time do I have left? This is my lab, by the way. I think all the work we did here is a effort from all the students here. Any questions?
All right, great. Thanks you for this fantastic talk. And let's open up the floor for questions. Feel free to just jump in with your question or raise your hands. And we also have a question from the chat from Vanshaj Kadir, and he's asking about Autoden in particular. Is this a white box or a black box model?
Yeah, it is a white box model. So here I had a slide which maybe showing here would be helpful. So this jailbreak objective actually requires backpropagation through the victim model. So it's a white box access to the victim model.
Mhm. Yeah, I think that clarifies. And we are not seeing your slides.
Oh,
No,
we are not? Oh, okay. Sorry.
no problem.
Uh,
Mhm. So let's see. I saw another hand raised by Nolan. Nolan, do you still have that question?
Yeah, yeah. So, thank you very much for that presentation. That was very informative. I had a question a few days ago. I believe it was on September 1st. Anthropic released their threat intelligence report from August, and it showed how Claude, specifically Claude Code, was being used for ransomware R&D and development and execution. And it was through social engineering. So the adversaries were claiming to be cybersecurity consultants, claiming to have like a legitimate use case and
yeah,
evaluating an infrastructure, but in reality, it was malicious.
yeah.
So my question is, I do a lot of research in neurosymbolic reasoning and formal verification, and I was wondering if you have any thoughts on how we might be able to train the reward function RXY in the auto-regressive reward model framework you outlined to kind of incorporate formal verification signals. So as an example, using like neurosymbolic approaches to verify user credentials or verify like they actually have a legitimate use case, i.e. they are a verified cybersecurity expert.
Yeah.
It's kind of like a hybrid model to distinguish between legitimate cybersecurity research and then malicious use during reward guided decoding.
Yeah, I definitely think reward guided decoding could help here. I mean, although it is a huge effort to come up with such a reward model, it requires a lot of training data. So that is one thing. My recent take on these kind of how to say more of like defending against these cyber security sort of threats. I think it's from a system perspective. Essentially, you could design some kind of protocols to come up with a system with a very specialized protocols to protect your AI system. For example, just as a very quick example, let's say you could have your AI agent going on the web, they have a link that you have to click onto and somehow take you to Reddit post. And there in the Reddit post, there is a jailbreak command. And you retrieve that Reddit post and therefore retrieve that jailbreak command, and then you were jailbroken. So that it is a very kind of strong attack for AI agents. However, if you were able to design a secure system, for example, separating anything that is acquired from the internet that is not trusted, you somehow code it in a way so that the language model never gets to see what is actually in that coded content that you retrieve from Reddit post. And in fact, you could just, you could have like two different language models. One is the more trusted one because every commands that the language model see is from your own command. But maybe there is another language model that is a lower privilege, but it sees all the untrusted content. But the language model, because it has lower privilege, it cannot do harm. For example, it doesn't have access to your bank account number. It doesn't have access to your email. It doesn't have this privilege to manipulate your compute system or something of that flavor. So maybe you have this kind of two language models. One deal with the trusted data stream, the other deal with the untrusted data stream. And you could have them play together to make your system more secure. So yeah, I think, having this reward model is definitely going to be helpful, but also designing from a systems perspective is probably going to be a very promising direction, in my opinion.
Okay, thank you.
Yes, I see hands raised by Ananya. So Ananya, go ahead, and then we have Zhongyang coming next.
Yeah. So it was a really nice talk and it was very interesting, Professor Furong. My question is that so like in practice it seems a bit impossible to like completely seal all security vulnerabilities in generative AI, right? So how do like researchers and practitioners like normally divide up, or how do we prioritize like which security issues like to address first, and like is there a criteria guide or like
That's a great
standards?
question. Yeah. If I understand correctly, I think the question was like, what are the most urgent problems in the security field that we should be taking on for now? Yeah. Correct me if I didn't understand correctly. I think there is a website. I forgot actually the name of the website, but I have to do some digging. There is a website that shows like the top 10 security concerns for AI systems. And I believe one of them is prompt injection. That is top 1 or 2 or something. And there is like unlearning as another one. So yeah, those two are very important as you see like prompt injection, because prompting is probably the 95% of our daily job as an AI engineer or AI scientist. And then, having third party giving you services, and then the users could utilize those services, but the user prompt will always be injected to some point. So, having kind of vulnerabilities to prompt injection is a huge security concern in the existing application domain, right? And unlearning is another one, although there is a lot of debate about, these unlearning kind of research that's been ongoing out there. But I think it's a huge problem. It's still a not very well solved problem. There is the concern about how these language models could fake alignment also, right? So like, assuming that I'm safe now, but later on, I could still, when I get more capable, I could still do some malicious things because my safety alignment is just faked. So, unlearning and, unlearning these, for example, just bioweapons is pretty crucial. If we wanted to open source these models and everybody will have access to these models, then we definitely want to make sure that these models do not create a AI apocalypse.
Yeah. So like, do we need to create like different models for overcoming these issues for like each different security concern like we are having, or like when we like if we create like
Yeah.
when we create sorry the uh, uh, like when we create this model like to counteract everything, then like does it consider like uh, having these security concerns with like the respective weightages,
I think
or
that's model governance, right? So it's an ongoing research field. There's a lot of debate about the capabilities of these models, watermarking these models and essentially making sure that we have governance over these models. I think some of us may argue, again, this is a little bit political. Some of us may argue that we should not have very capable open source models because malicious social actors could utilize these very powerful tools to do things that harm this entire human society, right? That is a risk. Somebody just mentioned such a concern in the previous question. But others may say, hey, we should always have the strong open source models. Then that's, when we could utilize the entire human society brain power to come up with defenses against these malicious, um, attacks, because we could utilize the power of language model um, as a defense. In my opinion, I think language models are still a tool, unless they develop their own will. I think they are still a tool. It's all about the social actors utilizing these tools, right? So you could have malicious minds, or you could try to do social good utilizing these tools. So we should have some sort of regulation and governance, and making sure that we have a system for attributing accountability, or kind of like making sure that we have some good regulations out there. Mechanism design is probably also
yeah,
very important here.
yeah, thank you so much.
Somebody just put the link here that I was talking about, the genai.owsp.org. There is large language model top 10. Yeah, that's the link.
All right, great. So, Zhongyang, I see your hand raised. Please go ahead.
Yeah, hello, Professor Huang. Yeah, I'm Zhongyang Li, and I'm a master student in Johns Hopkins University. And currently, I'm working with Professor Tianyi Zhou in UMD about the test time optimization in MOE models. So thank you for your talks today. I have learned a lot. And I have a question about the test time alignment. So if the test time alignment become good enough, well, we still need to do alignment during the training. So are the final goals of these two methods is the same? Yeah, thank you.
Yeah, that's a great question. I think they are complementary. So if you believe that there are some alignment that needs to be internalized to the model that is universal to different personalization or individualized value system, then I think that's basically a criterion for common value. And if that's common value, such as the language models should not remember how to make bioweapons. If that's a common value, then we should align that language model to not be able to come up with any bioweapons on its own, right? So those kind of common values should be hopefully internalized to the language model through some training methods, training alignment methods. Whereas this test time alignment, I think, is more of a flexible kind of paradigm. Under those scenarios, for example, you have very diverse value systems. You could on the fly steer those language model to very different value systems, right? Very personalized ones. And you could also cater to different needs, right? So let's say you have a need for helpfulness or harmlessness or some other needs. So can you satisfy all of them, right? Maybe you could get a real-time feedback from the user to adjust your coefficients of these objectives so that you could, serve them better. But if you internalize your model through this kind of training time alignment, then this becomes impossible, right? You cannot do a real-time adjustment of these coefficients. You have to predetermine what is the coefficient you align the models to, right? So that flexibility is there. Also, it's just much lightweight, right? Much lighter than these training time alignment. If you don't have enough GPUs, you could utilize this test time alignments.
Oh, okay, I see. Thank you.
Yeah, thank you.
All right, that's great. And we have a few more minutes for more questions. Yeah, maybe I can ask one.
Sure.
So you mentioned about integrating stress testing with alignment, and you also mentioned about the system level perspective of AI safety. So we've been exploring the idea of embedding the property of anti-fragility in AI systems. So essentially, AI systems that doesn't just withstand the stress, but gets stronger because of them. But in this process, I'm wondering your thoughts of how do we ensure, as we have a more like self stress testing systems, that the system doesn't go off the rail and have some undesirable behaviors. And in terms of the research questions and challenges, what do you see as the key to enable an AI systems that can stress test itself and get stronger?
I see. Are you thinking about like real-time stress testing so that the system would actually interact with the real environment and could potentially do real harm? Or is this all hypothetical?
So I think it could happen at either the test time or the training time. But the test time is where they see the vulnerabilities and needs to do adaptation. So I guess it's like different phases. You can still like integrate this stress testing.
I see. I guess there is your concern is that whether the stress testing themselves will create some problem, because stress testing is basically a malicious challenge to the language model, right? My take on this is yes, maybe we should have like a good evaluation system such that when we do the stress testing and potentially we change the weights of the language model, we could make sure that the updated language model doesn't, first is usable, but also doesn't do other harm. So maybe the evaluation system is pretty important to have, to make sure that when you put them out there for use, it is not, it is doing what we expect them to do.
Yeah, thanks for sharing that perspective. Yes, indeed, I think monitoring and evaluation is critical, and it connects to some of your previous works on this topic as well.
Right. So I didn't mention that, I thought that I wouldn't have time to talk about it, so I didn't put it on my slides. Turns out I was very fast today. So we had to work on agentic defense, which I think is very interesting. If I knew I had time, I would have included here, which is essentially saying like your language model could create a multi-agent system, like an agentic framework of a workflow, so that they could actually reason about whether there is jailbreak prompts or there is a malicious request. And that way is a test time kind of defense, which essentially not only make sure that the language model is usable, has high usability, so it doesn't, say no to these reasonable requests, but also make sure that it reason about the safety of the question and safety of the response multiple times through this kind of safeguard rail from a system perspective. So we call that system scaling, so that you can have more agents serving as guardrails to reason about the safety of these responses. It's called Aegis LLM. If you guys are interested, you should feel free to take a look at that.
Yeah, it sounds very interesting. Thanks for sharing.
Thanks.
Okay, so we have maybe a quick question from the audience. Yes, Aishan, your turn.
Hi, Professor Huang. Very yeah, I learned a lot from your talk. And what's your opinion? Because now I mean, I see a lot of AI generated content on the internet. And also, what do you see? And also a lot of models that are trained on those synthesis data. However,
Synthetic data, right?
yeah. Do you think this might be a threat for LLMs or?
Threat, right. Depending on whether the synthetic data is harmful or not. Yeah. So first of all, AI generated content is a huge topic, and a lot of us are very interested in. I think you know, it's still a very you know, up in the air field that requires a lot of thinking and protocol design and so on. But then I'm actually not against training from synthetic data, because I believe that we're running out of data, especially for you know, for larger models. If you look at the scaling laws, we're right at the boundary that we've used all the internet data, you know, all the tokens on the internet. Of course, the high quality ones, right? There are a lot of low quality ones that's probably very harmful. So I think this is probably the time to think whether we can generate synthetic data and whether we can ground the generation of the synthetic data to the real world. And the grounding seems to be very important. My lab has been also working on this field right now to make sure that synthetic data contributes to model training and make sure that the synthetic data quality is grounded through some kind of verification process. In that way, you could even hope that the language model could self-improve, in the sense that it could generate data, and then there is this grounding process to make sure that data generation quality is good, filtering out bad data, do some curation autonomously, and then utilize that generated curated data to you know, fine-tune the model again or align the model again. So it could create a self-improving loop.
But the thing is, because what if it generates some like untrusted data?
Oh, yeah. So that's the grounding part that you could, yeah, exactly. I think everything that, you know, devil in the details for sure. So everything is sort of in that grounding process that you just want to make sure that the data has been curated and been grounded and filtered so that there is only good data left.
Okay. Thank you.
Yeah. Thank you.
Okay. Yeah, on that great note, this pretty much the time for this seminar. Let's give Furong another warm applause for the fantastic talk and discussions. And thank you all for your engagement. Hope to see you all in our next seminar. Have a great weekend.
Thank you so much. This is really fun. Yeah, I'm glad I'm here, and thank you everyone for your time.
Thanks, Furong. Take
Okay,
care.
take care.